contract announcement said. Boeing won the initial contract for the APORS project last year and hired B Systems as the primary subcontractor. Overall, the U.S. Air Force is vigorously upgrading the 1980s-era F-15 fighter by giving new weapons and sensors in the hope of maintaining air-to-air superiority over the Chinese J-10 equivalent. The multi-pronged effort not only includes the current edition of electronic warfare technology but also extends to super-fast high-speed computers, infrared search and track enemy targeting systems, increased networking ability and upgraded weapons firing capability. The Air Force plans to keep the F-15 fleet in service until the mid-2040s. Many of the F-15 systems date back to the 1970s and must be upgraded if the aircraft is to remain operationally effective. Various upgrades will be complete as early as 2021 for the F-15C ASA, Active Electronically Scanned Array, radar, and as late as 2032 for the various electronic warfare upgrades. The Air Force currently operates roughly 400 F-15C, D and E variants. A key impetus for the upgrade was well articulate in a congressional report on the US and China in 2014. US-China Economic and Security Review Commission www.usc.gov. Among other things, the report cited rapid Chinese technological progress and explained that the US margin of superiority has massively decreased since the 1980s. As an example, the report said that in the 1980s, the US F-15 was vastly superior to the Chinese equivalent, the J-10. However, Chinese technical advances in recent years have considerably narrowed that gap to the point where the Chinese J-10 is now roughly comparable to the US F-15. Air Force and Boeing developers maintain that ongoing upgrades to the F-15 will ensure that this equivalence is not the case and that, instead, they will ensure the superiority of the F-15. Among the upgrades is an ongoing effort to equip the F-15 with the fastest jet computer processor in the world, called the Advanced Display Core Processor, or ADCP. High-tech targeting and tracking technology is also being integrated onto the F-15, Gibbons added. This includes the addition of a passive long-range sensor called Infrared Search and Track, or IRST. The technology is also being engineered into the Navy F-18 Super Hornet. The technology can detect the heat signature, often called infrared emissions, of enemy aircraft. The system can simultaneously track multiple targets and provide a highly effective air-to-air targeting capability, even when encountering advanced threats equipped with radar jamming technology. IRST also provides an alternate air-to-air targeting system in a high-threat electronic attack environment. The F-15 is also being engineered for additional speed and range, along with weapons firing ability. The weapons carrying ability is being increased from 8 up to 16 weapons. This includes an ability to fire an AIM-9X or AIM-120 missile. In addition, upgrades to the aircraft include adding an increased ability to integrate or accommodate new emerging weapons systems as they become available. This is being done through both hardware and software-oriented open standards IP protocol and architecture. The aircraft is also getting a fly-by-wire automated flight control system. Fly-by-wire means when the pilot provides the input, straight to a computer that then determines how to have the aircraft perform the way it wants, provides electrical signals for them more quickly and more safely move from point to point as opposed to using a mechanical control stick. Along with these weapons upgrades and other modifications, the F-15 is also getting upgrades to the pilot's digital helmet and some radar signature reducing, or stealthy characteristics. However, at the same time, the